Okay, you guys already found probability. Maybe you didn't know that's what you were finding, but when you find a percent in our colors of our M&Ms, then that's finding the probability. Okay. So to find the probability of something, you put on the top your favorable outcome over your possible outcomes. Okay, so in this case we're talking about our M&Ms. If we wanted to pick a blue one, we wanted to look at how many blue there were versus how many total M&Ms we had. Okay. Conditional probability then contains a condition that may limit the sample space. So we had all of our M&Ms, okay, but then I wanted to limit it to only look at either the red ones or the peanut butter ones. Okay, that's a condition. Conditional probability is written as P is the probability of event B. The line means the word given. Event A. And it reads the probability of event B given event A. Okay, and it's the probability of B given A equals the probability of A and B divided by the probability of A, where the probability of A cannot equal 0, because you can't divide by 0, which we've already talked a ton about in chapters 9 and trig. Okay? So let's see how this works. So you're going to be given a wonderful chart like we had with our M&Ms, and I need you to total everything out for me. So add up everything. You're going to want a calculator this chapter, so if you don't have a calculator, bring a calculator and not your phones, because you can't use your phones on the test. And you're going to need a calculator for this test. Okay, you can check your numbers with my numbers and see who's right. Oh, I'm running out of colors. Now I need purple. The color. Okay. Do these numbers look good to you? Okay. Hopefully they worked. Okay, so the first couple ones are find the probability that a material is recycled. So we're looking at everything. There's no limit to this, so you're going to use that total number. The 2292, that's the total amount of stuff I have. And I want it recycled, so I want to look at how many recycled things I have, which is 680. Then we're going to divide that and write it as a percentage. And I have 0.296. So in a percentage, that would be 30%. Make sure you're round. Okay. Any questions over that? Okay, find the probability that the material is paper. So we're at 2292 over. And again, since there's no limit, it's just paper. Find the probability of paper. We're looking at everything. And then we want to look for the total of papers, which is the 818. Any questions over that? Okay, and then we divide that. And what percentage do we get, class? 35 or 36? 36%. Any questions over that? Okay, now we're going to use conditional probability, where we're going to limit our sample space. Okay? So to find the probability that the material is paper given that it's recycled. So the probability of paper given recycled. Okay, so this means you're going to only look at the recycled column. Write it down. It's the second thing that limits it, okay? So you're only looking at the recycled column, which is right here. So on the bottom, we should have that 680, because that's the only stuff we care about. And in that recycled, how much of that is paper? 367. And what percent is that, class? 54%? Any questions over that? Okay, next one. Find the probability that the material is plastic given that it's not recycled. So plastic given not recycled. So again, we're only looking now the non or not recycled column. That's 1,612. I'm looking at not the recycled anymore. But the not recycled, which is plastic, which is 240. In class, what percentage is that? 15%. Any questions over that? Okay. Okay, let's do another one. This one's a little bit hard to look at because it has yes and no columns. Okay, we're still going to add everything up. Go this way, that is 81, this is 9, this is 59, this is 31, and this is 90. The first one is just has the diploma. It's not limiting anything because there's no line. It's everything. So on the bottom is everybody. Okay. And we want to look at how many people have a high school diploma. So that's our yes column at 81. So it's 81 divided by 90, which is about 90%, which is exactly 90%, I should say. Any questions over that? Okay, we want to see has a diploma and experience. So again, we're looking at our total number of people because there's no limit. But we only want to find the people who have a diploma and experience. So find those group of people. Eduardo, how many people have a diploma and experience? 54. It's the people who answered yes to my diploma and yes to experience. So it's this group, 54. I think that's exactly 60, right? So I need the equal sign. Exactly 60%. Any questions? Okay, this is what we're going to limit to now. Has a diploma. Okay, probably has an experience given they have a diploma. So we're only going to look at yes to diploma. So in our column, or in our chart, we're only going to look at this row. So that's 81 total people. Okay. And then Catherine, of those people, how many of them have experience? 54. And what percent is that? 67%? 66.666? Okay, so round up to 67. Any questions over that? Okay. Okay, everyone does 4 on their own. Okay, Nick, what row or column am I looking at? Where are you at? For this one, has no diploma, given, has experience. So which row or column am I looking at? Huh? Very good. This one, the people who answered yes to experience. That's what I'm looking at. I'm only looking at these people here. So on the bottom should be 59. Now in that column, okay, we want to look for the people that have no diploma. So Bishoy, how many people don't have a diploma? 5. So those are the numbers I should be using. 5 over 59. And what is that percentage, class? 84? That's a small number, right? What should it be? Everyone does 5 divided by 59. 10? 8? Yes, 0.08. So just so you know, 0.008 47. 4. So you move your decimal over twice, so that will give you 8%. Any questions over that? Okay, on the back. work on, well, let's total these out first. Make sure we have the totals right. Okay, let's add these all up. 6, 7, 8. Oh, I can't do that one in my head. How many people have bachelors? 1,456. Advanced degree should be 6, 6, 9. Okay. I'll let you guys total. Okay, we all good? These are the numbers we should have. Okay, so now you guys do these on your own. Remember, these first two don't have any limits, so you're going to use all of the data. Now these are going to have the restrictions. Okay, let's start with the recipient is male. Let's call on somebody. Noah P., what was your numbers that you put? $2,803. Okay, so we're looking at the males versus everybody. And what percentage did you get? 41%. Degree class? Yes. Okay, the degree is a bachelor's. Brett, what did you get?
1,456 over 2,800.
And what was your percentage? 2%. Any questions over that? Okay, the recipient is female, and the degree is advanced. Tanner, what did you get? What was on the bottom? Okay, what was on top? Okay, does that make sense? 700? So, okay. It's okay. And what percentage was that? 56. So again, on this one, you want to limit it to only the advanced. So you're only looking at these people. We take them out of our big pool of people. We put them in a separate place. Okay? And then we divide them. Okay. Now the last one. Darren, what did you get for the last one? Okay, so how many, what was on the bottom, first of all?
On the bottom, 2,125.
1667, that's the, oh, I just see male. Let's do males. How many people are male? 1136. That's how many were male. But that's the total number of males. Okay, and so you want to start with everybody first. And then on the top is where it's going to limit it to just the people with non-associate's degree, so just these people. So 598 plus 293, okay, which was 800 and what? 91 over 11,000, or 1,136. Okay. And then what percentage would we get? 78? Any questions over that? We're all good? Okay, hopefully that helps us. Now we're going to do our tree diagram. Okay, sometimes you don't have a bunch of charts, you just have a bunch of list of things that are occurring. Okay, so that's how this is how this works. A student in Buffalo, New York made the observation below. Of all snowfalls, 5% are heavy, which by definition is going to be at least 6 inches. After a heavy snowfall, schools are closed 67% of the time. After a light snowfall, less than 6 inches, then the schools are closed 3% of the time. To organize your data, you're just going to do a little flow chart. Okay. So I'm going to start here and have 2 parts. We want heavy snow versus light snow, because those are our 2 options at the very beginning. Okay, of all snowfalls, 5% are heavy. So we want to write that as a decimal. So 5% has your decimal here. You want to move it over twice. So it's 0.05 goes here. Any questions over that? Okay, if we're referring to snowfall, when it's snowing, it's 5% chance of it snowing heavily. How often will it snow lightly then? 95%, because you want it to total to a whole. Okay, so light snow is going to occur then 0.95. Just subtract from 1. Then after a heavy snowfall, so we're going to look at the heavy, and there's going to be 2 things that occur. Schools are closed. Okay, so they can be closing school, or they can open school. Okay. And schools are closed 67% of the time, so 0.67. That's a decimal. If they are closed 0.67, how often are they open? 0.33. Because again, you want it to become a whole, 1. Then it talks about after a light snowfall. So we're going to do the same thing on the light. Okay. Schools are closed only 3% of the time. Okay, so we're closed 0.03. Then we are open 0.97 of the time. Does that make sense? Now I'm going to use that like flow chart, or they call it a tree diagram, to answer the following questions. It says find the probability that the snowfall is light and the schools are open. So light, and the word and in probability means to multiply. So we want to multiply the probability of being light, which is 0.95, times the probability that the schools are open. And schools are open 0.97. And that would be 0.9215. So that's about 92% of the time schools are open. Any questions over that? Okay, the next one says find the probability that the school is open given there's heavy snow. So only look at heavy snow. So we're only looking on this side. And if it's heavily snowing, how often are the schools open? 0.33. So 33% of the time. Any questions over that? Okay, I want you guys to try and draw your tree diagram for this one. You can just draw it here. Probably the easiest way to do that. Okay, so let's see how we did. Okay. Of all the respondents, 17% are male. So this is going to be male, this is going to be female. So we should have 0.17 here. And then 0.83. Thank you. Right here. Then of the male respondents, 33 are left-handed. So this is going to be left-handed and right-handed. So 0.33 are left-handed. So 0.67 are right-handed. Of the female respondents, 90% are right-handed. So 0.90. That means 0.10 are left. Now, you don't have to have them in the exact order that I have. Like, you could have switched the right and the left, or the male and the female even, okay, as long as it kind of flows like that. Any questions over how we got this? Okay. Then we want to find the probability a female respondent is left-handed. Okay, so we're only going to look at the female respondent. What is the probability that they are left-handed? 10%. Goes with this one above. Okay, a probability a respondent is both male and right-handed. Okay, so and again means multiply. So I want to find the probability of being male, which is 0.17, times the probability of him being right-handed, 0.67. Use your calculators for me. Do I have 11%? And that's about 11%. Any questions over that? We're all good? Okay, you guys have a worksheet, 12.2. You guys can start working on that right now.